The objectives of the study are identify and compare the characteristics and features of those productive intrusions and the non-productive intrusions surrounding and extending out up to 50 kilometers from the productive Peñasquito diatreme-porphyry complex. Provide a basic understanding of the nature, style of mineralization and hydrothermal alteration of each locality. Provide a general petrological, petrographic, and geochemical characteristics of the different intrusive igneous phases or events in each locality. Determination of radiometric edges, mainly of the hydrothermal alteration products, and compare all the data generated in terms of the productive versus non-productive igneous phases with the Peñasquito diatreme system in order to provide a brief guide that may facilitate the future exploration in the region. So the research includes 7 stages, including fieldwork and laboratory. We start the fieldwork with the outcrop style geological mapping, including recording all the structural features as hydrothermal alteration evidence at surface. Core logging with selection of samples in order to complete petrographic and petrological analysis, using or paying a lot of attention of the characteristics of the magmatic pores in order to determine the characteristics of the magmatic fluids. We did that with the study of fluid inclusions of these phenocryst quartz. We also complete a whole rock major, minor, trace, and rare elements in order to interpret the geochemical signature of these rocks. The radiometric edges of the hydrothermal alteration products, and finally the comparisons to those data with the Peñasquito diatreme-porphyry system. The study area is located in the central north part of Mexico. The main reference is the Concepción del Oro district, and lies in the northeastern part of the state of Zacatecas. Includes 6 localities. These study sites were selected and established and outlined with regard to the gold core mining claims and exploration drilling programs within this regional study area. Although I have to point that due to time constraints regarding the exploration progress stage at each locality during the fieldwork seasons, the amount of available data collected and analyzed are different for each site. As an example, Melchor Ocampo, which is the northern locality, during the second field season, the exploration drilling program was just starting. They have complete just 2 drill holes, and none of them hit any igneous interval. So all these samples from this project were taken from outcrop. So the 6 sites include Noche Buena, Melchor Ocampo, Providencia, Santa Rosa, Camino Rojo, and El Saltillito. Well, the tectonic settings of this portion of Mexico is quite complex. The configuration is related with the progression and regression of arcs, continental arcs, volcanic arcs, and also major structures such as the Mojave Sonora megashare or the Mexican fault and thrust belt, outlining it in this portion, made quite complex the study from the tectonostratigraphic point of view, this portion of Mexico. So basically, the tectonic zeniths that allow the stratigraphic column in the area start during the Triassic. So we have during the early Jurassic, middle Jurassic, volcanic iron style that allows the deposition or the nacest formation, evidence by a volcano-sedimentary sequence in this portion. Then during the early Cretaceous up to the Aptian and Albian, passive regime was prevailed, that this allowed the deposition of a thick marine sedimentary sequence formed by limestones and siltstone and sometimes chert. And then by the end of the Campanian, another volcanic arc were installed in the east of Mexico, which also is responsible for the accretion of the Guerrero terrain. Once the Guerrero terrain was accreted to the nuclear Mexico, the clastic sediments apport to this four arc basin, and the last or the youngest Mesozoic units were formed during this time. So the youngest units have several package of sandstones, including the one of the best host formation for mineralization. During this time, late Mesozoic, the compressional tectonic zenith lead for the beginning of thin skin deformation around 92 MA, deformating all the marine sequences, and is also known as a laramide orogeny. And syntectonically occur some intrusive emplacements such as the Pico de Teira and El Peñuelo intrusives. So after this deformation conclude, immediately post-tectonic igneous event occur, and El Saltillito intrusive were in place. There are several studies that shows or provide evidence why this occur, because commonly the El Saltillito igneous body doesn't show any deformation. So after that, during the Cenozoic, we have a series of intrusions, especially in the Eocene. And normally this volcanic or igneous activity occur in the transition from a compressional tectonic settings to extensional tectonic settings. So during the Eocene, several igneous bodies were in place, including the Concepción del Oro, Nochebuena, Peñasquito, Melchor Ocampo, and Santa Rosa. And we have evidence about the extensional tectonic settings by some fissural basalts in the same area. So one of the tectonostratigraphic configuration, as I mentioned, is complex, and also all the tectonic structures, features in this region are complex. So this is because in the same time that the compressional tectonic setting was shortening all the units, we have several elements such as these carbonated platforms that allows or are the responsible to the current structural configuration in the area. So we have several arc fronts, and then we have these uplifted areas that allows to form a series of anticlines and synclines in the region. Whoa. I have been, sorry about that, I have been a small. Okay, so the main tectonic features are configured for those uplifted terrain, as I mentioned, and we have a series of structure northwest oriented. The mainland direction is this, but sometimes they deflect in a west east oriented because this uplifts terrain. So the area is located between the Mexican Fault and Thrust Belt, also known as the Sierra Madre Oriental, and the geologic province, the Mesa Central. This is remarkable because the Mesa Central is delimited by a series of fault systems where most of the major ore deposits are located. So we have here an example in the system, the Tasco San Miguel de Allende system fault is located at the Zacatecas district, Fresnillo, Sombrerete, and Durango. Whereas in the San Luis Tepehuanes fault system, we have Cerro de San Pedro, Sierra de 14, La Paz, and then we already know that here in the northern border of this, the Mesa Central is located Camino Rojo, and further northeast we have Concepción del Oro and the localities that I have in this study. Okay, the regional geology, as I mentioned, is formed by a thick package of marine sedimentary units, especially in the study locations. We share the same lithology, starting with the Zuluaga Formation, which is late Jurassic in age, then La Caja Formation, Tarais Formation, Cupido Formation, La Peña Formation, Cuesta del Cura Formation, Indidura Formation, Caracol Formation, and Parras Formation. Commonly, all the units are host or in some grade mineralization, and we will see that according that the geological structure that is present in each locality, is the style of mineralization present at each unit. So we have several intrusions. Commonly, all these intrusions are associated or are known as a Concepción del Oro intrusive belt. Is conformed by several intrusions. Two main igneous activities. The late Mesozoic includes the Peñuelo intrusive, Matehuapil intrusive, Rocamontes, El Saltillito, and we will see that Camino Rojo will be included in this main activity during the late Mesozoic. It's also known as the eastern portion of the Concepción del Oro intrusive system, whereas the western portion of this belt is conformed or includes Nochebuena, Melchor Ocampo, Providencia, Santa Rosa, and we already know that Peñasquito will be included in this portion. All the marine sedimentary units is around 2 kilometers in thickness, so there is a lot of potential for host mineralization in this region. So the local geology at each of the sites was, as I mentioned, was made or obtained from the Goldcorp mapping, in addition with outcrop styling observations that I did during the fieldwork. So we can see here the Nochebuena study area. This is one of the portion of the entire Nochebuena district, but as I mentioned, all the localities were regarding with the Goldcorp claims. So commonly, the Nochebuena district is associated with a style of mineralization, including chimneys and mantle replacement. But here specifically, the exploration were focusing on the porphyry type mineralization. So the values of this mineralization were mainly gold and copper. And we can see the intrusive phases in this portion, where including quartz monzonite, a monzonite, and granodiorite. The main phases associated with the mineralization are the QS quartz feldspar porphyries, and seems that in this locality the granodiorite is unrelated with mineralization. So therefore the main hydrothermal alteration associated with the mineralization is potassic alteration overprint by QFP alteration. At Melchor Ocampo is also located in a regional syncline, although locally a small anticline structure is present among or within the intrusions outcrops. Here, the intrusion composition is a monzonite, although some studies shows that there is a small variation to granodiorite here in the northern part of the district. And we can see even during the field season, we just mapping dike type outcrops. We are inferring there is a big igneous mass beneath the surface. Here, the characteristic, the hydrothermal alteration is characteristic is phyllic, and in some grades calcilicate alteration as well. At the Providencia study site, we include this locality in terms of try to enhance the big pictures, although the fieldwork consists just in 2-day visits to the underground mine. So for this research, all the samples were took in the underground mine, and from a few of them were took from drill holes. But in this slide, you can see the location of uranium lead dates samples that were used by Valencia in 2010. So commonly, all the localities that are located, or all the district that lies in the ranges, are located in an anticline. Commonly, most of them are overturned anticlines, and sometimes is associated, the intrusion is use reverse fault as a part of the intrusion, of the emplacement. For the Santa Rosa study site, we have the same configuration. We have the core of the anticline in the center of the study area, formed by the Zuluaga Formation. And again, is a overturned anticline. And here the intrusions are consist of quartz monzonite, and granodiorite. And here is both or the three phases are related with mineralization, though the granodiorite is more related with a Chimene and manto type style of mineralization, whereas the quartz monzonite is related with stonework and veinlet breccia mineralization. For the Camino Rojo, is one of the second important ore deposit in this region, especially because this deposit will be in production next year for Orla Mining Company, and they consider up to 8.3 million ounces of resources proven and interpreted. So as you can see, the geological map, this ore deposit lies in a flat topography. You cannot see a lot of outcrops, only by trenches. So we can see here the panoramic photographs of the first discovery site, which is known as the Represa site, and also the geologists that discovered this deposit. The very first works to study this site were 2 trenches, and they found the formation host here is the Caracol Formation. So you can see here a little bit of argillic and QFP alteration, but just by trenches. So most of the work in this study came from drill core samples. At the Saltillito study site, again, is located in a regional anticline, but the Saltillito range form a small anticline. The sedimentary units present in this region are Hendidura, Cuesta del Cura, Hendidura, and Caracol formations, and are intruded by a quartz monzonite intrusion. And in this portion, the associated mineralization is gold and copper, and the main hydrothermal alteration is calcilicate alteration. So we have a lot of hornfels formation with this in the contact between the intrusion and the sedimentary units, in addition to banded skarn with andradite and pyroxene bands. So I need to point out that closer to the intrusion where is located the main mineralization increase the amount of andradite, whereas in the farther portion of the skarn, the pyroxene prevails. So all the samples were selected according with high-grade gold assays, in addition to textural changes in the intrusive intervals, changes in the alteration, mineralized veinlets, spatial distribution, depth, and drill hole locations. As I mentioned, not all the samples were taken from drill holes. So at Machoro Campo, mainly were outcrop hand samples, and also in Santa Rosa. All the samples were stained with sodium cobalt nitride in terms of observe the potassic feldspar alteration, as you can see in these samples. So all the igneous rocks in the study sites are mostly intermediate in composition. We have commonly quartz monzonite and monzonites in all the localities, but some variations regarding with the mineralogical modal content. But we can see Noche Buena, quartz monzonite, quartz monzodorite, and granodorite. And here the copper gold porphyry type mineralization is related with the monzonite intrusives. Whereas Melchor Campo is by the petrological analysis, we established ore blend biotite monzonite. Terminal de Providencia is characterized by a monzonite, quartz monzonite, and granodorite. As I mentioned, the granodorite is related with the Chimene Amanto type mineralization hosted by the Zuluaga Formation, whereas the monzonite and quartz monzonite intrusive are related with stonework lode mineralization hosted commonly in the Cuesta del Cura and Hendidura formations. At Santa Rosa, we have monzonite, quartz monzonite, and granodorite. It's the same thing as Alaverna. Granodorite is more related with the Chimene type mineralization at Zuluaga, whereas the monzonite is related with a stonework and disseminated mineralization. We can see one of the main features of these igneous bodies. The reabsorber quartz is a key feature in these productive phases. In a hand sample, is known as A quartz. At Camino Rojo, even the exploration drilling program didn't hit the main intrusion, the main intrusive body. All the igneous rocks or intervals in the drilling, in the core drilling, are formed as a dike, but we defined by petrology andesitic porphyry and as a quartz monazite in composition. Here, the main alteration is potassic alteration overprinted by phyllic alteration. At Saltillito, we have an ore blend biotype monzonite, which is related with the mineralization, a first stage of potassic alteration, and the one of the most important alteration as well is calcilicate alteration. The whole rock geochemistry interpretation, we can divide in order to see the best behavior of the samples. The late Cretaceous intrusions, including Camino Rojo and Saltillito. We can see that the main chemical composition is intermediate, classified as a diorite or quartz diorite, although we have several samples plotted in the cyanide field. This as well in the Eocene intrusions can be related with the hydrothermal alteration, that is adding some potassium to the original composition of the rocks. So the same thing for some of the Peñasquito samples are highly rich with silicate. So one of these, or possibly most of these samples are hydrothermal alterated. The trace element spike diagrams shows very trends or trends very similar among all the localities, with a characteristic negative anomaly in neodymium and tantalum, characteristics of volcanic arc tectonic settings. In addition, we can see some negative anomalies in strontium, but this will reflect the fractionation of the plagioclase. So as you can see, some of the rocks are relatively, there is a small difference that indicates that the magma source was quite different, or there's difference about those magma sources. The classification using less mobile elements shows that most of the rocks are intermediate in composition, and there is not much, there is not a wide distribution. So we can infer that all these rocks start, or the magmas are essentially, the magma source were quite primitive at the very beginning. The tectonic settings regarding or according with the geochemistry signatures are related with a volcanic arc granite. And we can see in the ternary diagram quite variation in the rubidium concentration, that indicates the hydrothermal alteration plays a major role in these intrusives. One of the things that is remarkable is the best or the most important deposits in the region are Peñasquito and Camino Rojo. So as you can see in blue empty rhombus are the Peñasquito samples, and you can see a wide variation in the rubidium concentration. The other one is Camino Rojo, which also shows or exhibits a quite variation in this rubidium. So this will be a key factor in order to determine the difference between productive and non-productive igneous phases. The rare element spider diagrams exhibits traditional signature of subduction tectonic settings, and we can see a relative enrichment of the light rare elements, whereas depletion of the high rare elements. And we can see the European negative anomaly, which indicates fractioning in the plagioclase. So according, or whereas the rock became more evolved, we have a more negative anomaly on the European. So we can see the same trends for the whole units, though we have relative enrichment, especially comparing with the Peñasquito trend. So we can see that the magma sur, especially at Nochebuena and Melchor Ocampo and Camino Rojo, seems to be more primitive than the Peñasquito and the rest of the localities. So using trace elements discrimination diagrams, we can see that all the rocks are, as I mentioned, related with a active continental arc, and seems to be that the source, one of the possible source of these magmas was enriched mantle zone, and seems like most of the rocks experience the same differentiation process, which is fractional crystallization. Although we can also talk about crustal contamination. Here in this diagram, you can see that even though the main or one of the possible sources are the mantle, we also can be talking about deep crustal recycling, or talking about the lower part of the continental crust. So the age of the system, as I mentioned earlier, we can consider two main igneous activity in the region. Commonly in the eastern portion of the study area, we have the late Mesozoic intrusions, and we can see Sanchez 2017 provide or perform uranium-lead dates for the Camino Rojo intrusive, and is about 73 MA, whereas Saltillito, Valencia obtained 71 MA for this intrusion. Then we have a continuous igneous activity from during the Eocene, early Oligocene, starting with about 46 MA at Santa Rosa, followed by the Providencia intrusion about 40 MA, and then pretty consistently the Nochebuena intrusions between 36 and 37 MA. And the youngest activity includes the Peñasquito ore deposits, where the intrusion phases are about 34 MA. We can see that we have some samples older at Peñasquito. These come from these measurements about 46 MA were obtained in 2 visit samples in the diatreme breccia. So Macario Rocha conduct the study of the Peñasquito deposit. So he is interpreting that the volcanic or the igneous activities start at the 46 million contemporary with the Santa Rosa one. Then they have another sample of about 42 MA, the same thing. And another study shows younger igneous rocks at Providencia and Santa Rosa. Although for the location of these samples shows that this sample at Santa Rosa were taken in the Las Águilas intrusive dike, so can be the last activity, but just small dikes in the area. And these sample from the Providencia correspond to porphyry type samples here, so can be the last pools of magmatism in this area. So the thermal alteration present in the areas, I already mentioned some of them, but here is a comparison with the Peñasquito one. At Peñasquito, we have two main hydrothermal alteration. The potassic, both are related with mineralization at several stages, but we have mineralization related with the potassic alteration and the phyllic alteration. Also, in different levels of the deposit, we also is possible to see, especially at the outer parts of the deposit, a propylitic alteration and calcilicate alteration in some levels of the system. And finally, post-mineralized alteration formed by carbonate silicate alteration. So in the Nochebuena, at the copper gold mineralization, the main hydrothermal alteration associated with that is the potassic alteration overprinted by phyllic alteration, though in several levels we can see propylitic, especially in the outer parts of the system, as the Peñasquito one, and in the limits, in the borders of the intrusions and the sedimentary units, we can see moderate to pervasive calcilicate alteration. So at Santa Rosa, the main alteration related with the mineralization is the phyllic alteration, though we can have present some potassic, propylitic, argillic, and calcilicate alteration. At Providencia, the main alteration related with the mineralization is QFP, whereas also important alteration related with skarn mineralization is, of course, the calcilicate alteration. At Melchor Ocampo, the best or the hydrothermal alteration that enhances the mineralization is the potassic alteration, the same thing, overprinted by phyllic alteration. Although superficially there is some evidence of calcilicate mineralization related. At the Peñasquito, at the Camino Rojo, sorry, we have potassic alteration overprinted by phyllic alteration. And in this study, all the samples studied under the microscope and all the samples collected, we think that potassic alteration is related with the gold mineralization. Those scientists have a different opinion, and she think that pyrite, quartz, calcite can be also responsible for some amount of the mineralization. So finally, at the Peñasquito, at the Saltillito study site, we have the main hydrothermal alteration is calcilicate. So we have also the hydrothermal alteration, and as I mentioned several times, we have two main igneous events in the region and are very consistent with this hydrothermal alteration. So we can see here in field icons, the uranium-lead H's for the igneous activity, and then in empty icons, we can see the hydrothermal alteration H's. So it's in a pretty good range with the intrusions. So we can establish from this that we have at least two metallogenetic epochs in the region. One during the late Mesozoic, and the other one mainly occurred during the Eocene early Oligocene. So is we talking about one metallogenetic epoch around Concepción del Oro, Peñasquito area, and then we have the Camino Rojo is included in the older metallogenetic epoch. And the study of the fluid inclusions on magmatic quartz shows different fluid inclusion phases. More commonly, all the inclusions are present in all the quartz. Here we have an example of a multi-phase fluid inclusion formed by vapor phase, either water vapor or CO2 vapor. The solid phase can be hematite, pyrite, and sylvite, alite, or gypsum, or argentite. So this represents salinities from 11 to 45 sodium chloride equivalents at Peñasquito, 40 to 30 at Nochebuena, 15 to 41 at Santa Rosa, 15 to 44 at Melchor Ocampo, and 14 to 30 at Saltillito, roughly. Unfortunately, the samples selected for fluid inclusion from Terminal de Providencia and Camino Rojo were too small during the thermoanalysis measurement, so was too difficult to obtain the salinities in these two localities. But commonly, we can see in the Wilcox vector diagram that mostly hydrothermal fluids were evolved or were influenced by either boiling, cooling, and in some cases, especially at Santa Rosa, also decreasing on the pressure. So comparing all the systems with the Peñasquito, we already mentioned that we have the same thing of intrusion in terms of composition. The mainly or the commonly associated with the mineralization are, or the best are the monsonites with their variations. Although, especially with the older sedimentary units, the best igneous phase are related with those mineralization are the granodiorite. The same thing, we have two main activities about from 70 to 73 MA for the Camino Rojo and Saltillito, and then from 46 to 34 MA in the Concepción del Oro Peñasquito region. The H's, we'll see already, are in pretty good range with the intrusions. It seems, or the hydrothermal alteration H's shows the Peñasquito is the younger one. Basically, all the localities are polymetallic. Mineralization at Peñasquito is the main element is gold, although considerable amounts of silver, lead, zinc, In the deeper portion of the system, we have enrichment of copper and moly. Whereas at the Nochebuena, in the older district portion, the mineralization was mainly copper, iron, lead, and zinc. But in the study area, the main mineralization is associated with gold and copper. At Santa Rosa, we also have gold, silver, lead, and zinc, with lesser amounts of copper. At Providencia, the main mineralization is related with copper, iron, and lead and zinc, but we also have amounts of silver and gold. Same thing at Melchor Ocampo, the characteristic mineralization is related with copper and gold, and lesser amounts of silver, lead, and zinc. Camino Rojo is classified as a gold deposit, although they have important amounts of silver, arsenic, lead, and zinc. Finally, the Saltillito, the historical production at this site was gold and copper, although we have evidence that the deposit also have considerable or economic amounts of lead, zinc, even from molybdenum. So I have already mentioned the style of the mineralization at all the localities, but the difference in, especially at Peñasquito, is the two diatreme breccias that form the main ore. The style of mineralization is related, or a key factor related with these type styles are related with the host rock. So the host rock at Peñasquito, the main or the bulk of the mineralization is hosted by the Caracol Formation, as the same as the Camino Rojo. So whereas the rest of the locality can be hosted by the complete sequence: Zuluaga, La Caja, Taraices, Cupido, Cuesta del Cura, Hendidura, and sometimes even Caracol formations. So therefore, geological structure are important for mineralization control. Since Nochebuena, Santa Rosa, Terminal de Providencia, and Melchor Ocampo are related with anticline structures, and Peñasquito and Camino Rojo and possibly El Saltillito are related or emplaced in syncline structures. So we can conclude from this research that we have the intrusive system around or surrounding the Peñasquito produced diatreme-porphyry system can be divided in two groups, as I already mentioned, based on the uranium-lead zircon edges and 39 argon edges of the hydrothermal products associated with these intrusive rocks. The first group includes Camino Rojo and El Saltillito intrusive systems, including in the western portion of the Concepción del Oro intrusive belt, whereas the second group includes the Peñasquito, Santa Rosa, Concepción del Oro, Providencia, Nochebuena, Melchor Ocampo intrusive systems, mainly Eocene-Oligocene age. So the Camino Rojo and El Saltillito are, as I mentioned, part of the eastern portion of the Concepción del Oro intrusive belt, whereas the rest of the localities are included in the western portion. So associated mineralization of those igneous centers can be categorized based on two different metallogenetic epochs present at the Sturi area. This came out because, especially at the Camino Rojo ore deposits, at the very beginning, before we have evidence both from the igneous activity age and the hydrothermal alteration, was considered to be very similar to Peñasquito or deposits. So based on the whole rock geochemistry, we established that the magma source of both system, late Mesozoic and Eocene igneous activity, can be derived from the partial melting of the mountain wealth generated during a subduction tectonic setting. The geochemical analysis suggests that the differentiation process was extremely complex, not only as inside of each system, but within the system intrusive phases. In addition of this magma source, we have evidence that crustal crust contamination plays a major role in during the differentiation process of these rocks, and at the end is a key feature in order to develop or to enhance mineralization in these localities. So finally, surrounding intrusive system range in composition from quartz monzonite, monzonite, quartz monzonite, quartz monzonite, monzonite, quartz monzonite, and granodiorite. And essentially all of them are associated with mineralization, especially related with the host formation. Therefore, productive versus non-productive intrusive phases are in function of the geochemical composition of the magmatic fluids more than the igneous mineralogical modal content. So, mineralization style and mineral grades within the study areas are determined by several factors, or the convergences of this factor. First, the regional geologic structural controls, such anticlines, syncline structure, or basement deep faults. Also, the local geology structural controls, such as faulting, fracturing, and sometimes depreciation in the either in the igneous phases or intrusions or in the host rock. Properties of the host rock, such as lithology, permeability, or porosity, chemical composition and temperature of the hydrothermal fluids, and interaction with the water table. So in terms of mineral exploration, it is considered that in the study area, currently, in terms of the stage of exploration in the region, the more favorable structures to host major mineral concentrations are the synclines. As an example, the Peñasquito and Camino Rojo. This because magma interaction occur with the entire stratigraphic column, allowing magma differentiation by assimilation of the host rock material that yield increase in the water content, which is a prime factor for mineral deposition. So the potential for this region is big enough in terms of the only two deposits located in those valleys are Peñasquito and Camino Rojo, and turns out that are the most important nowadays. So I want to express my gratitude to a lot of people. I cannot mention all of them, but firstly, I want to thank you, my wife, Aide, my children, Diego, Jimena, and Dana. Without their support, I won't be able to complete this dissertation. So quite simple, the doctoral degree at UNR won't be possible without the sponsorship and support of the SGM. My deepest gratitude to Dr. Tommy Thompson and Mike Ressel. They have a lot of passion with me. Their guidance was undescribable. Also, I received a lot of support for the CREC under the direction the Tommy Thompson, John Monty, and a special thanks to Dr. Peggy Arps, because without her support and encouragement at the last stage of this research, I will make it. So thank you so much. And I don't know if you have questions. Thank you.
Gilberto, if you can now stop sharing, and then we'll go into the question mode.
Okay.
Thank you very much. That was a very good talk.
Oops.
I think everyone should be able to hear me. I'm not sure if you have the raise hand icon at the bottom of your screen. If you do, use it if you have a question, and I'll be able to see your hand. If not, you can also use the chat function, also an icon at the bottom of your screen, to ask a question, or I can unmute you as long as I know who you are. So any questions for Gilberto? And again, Gilberto, thank you very much. That was a very good talk and very informative.
Thank you.
So questions from the audience. Pretty remarkable, since Gilberto is about 3,000 kilometers away from many of us here in